Original and sophisticated engineering innovations have always been a hallmark of Alfa Romeo's new products. The new 33 sedan ranks among the most advanced levels in the medium-high CC bracket due to the combination of results that till now were considered impossible to bring together. The design of this car has been based upon a number of innovative techniques, but the main features are incorporated in the new 16-valve Boxer engine. These features have led to high specific power, high torque even at low revs, low fuel consumption and very low pollution emission levels. The advanced techniques introduced on the four-cylinder, fuel-injected Boxer engine have entailed the adoption of a belted twin camshaft with 4 valves per cylinder. These are fitted with bucket-type tappets. The combustion chambers are partially machined in the pistons, which are slightly concave, and the spark plug is located centrally. This extremely modern system embodies the design features which make this engine into a superior 4-valve power unit. Valve timing. Before dealing with this subject, it should be mentioned that the electro-injector, as may be seen from the head cross-section, is offset in relation to the center line of the intake manifold, and the jet is mainly aimed towards only one of the 2 intake valves. Let's now take a closer look at the valve sequences. Towards the end of the expansion stroke, the 2 exhaust valves work in 2 different times. This helps the swirl in the combustion chamber. One of the 2 intake valves opens well in advance of the top dead center. As the electro-injector is located near the other intake valve, this valve admits weakly carbureted air, which swirls at great speed, because its specific weight is much lower than the average weight of the mixture of air and fuel. Subsequently, the other intake valve opens with a lower lift, through which richly carbureted air flows. When the 2 flows meet, as mentioned previously, one flow has already begun a fast vortical motion. The mixture is swirled and homogenized. This facilitates complete combustion. The exhaust valve opposite the intake valve nearer to the electro-injector closes first. This prevents unburnt fuel from reaching the exhaust, hence reducing pollution. The second exhaust valve has a longer crossover sequence and closes later. Once the compression stroke is underway, the 2 intake valves close simultaneously. Fuel system. As mentioned previously, the electro-injectors are offset in relation to the center line of the intake manifold, and they are located next to the valve which meets less with the corresponding exhaust valve. The fuel injection system is fully computerized through the adoption of the Bosch Motronic system. This is currently the most sophisticated system available on the European market. The use of one throttle valve per cylinder has found widespread implementation on high-class carbureted cars, but it's still fairly unusual for fuel injection systems. The reason behind the presence of one throttle valve per line on this engine is due to the adoption of wide crossover timings. This type of timing, particularly at idle rev, involves the backflow of unburnt gases from the exhaust towards the intake manifold. One throttle valve per cylinder prevents the pollution of the whole intake manifold. This way, the quality of the fresh air taken in by the adjacent cylinder is not jeopardized, with no adverse effects on the ignitable properties of the mixture. Consequently, smooth engine operation is guaranteed. This has enabled the adoption of high crossover values between intake and exhaust, through which the high torque rates at low and average speeds have been attained, as shown in the graph, which compares the torque curves of the 16-valve engine with and without 4 throttles. More precisely, the torque curves of the new electronically injected 16-valve engine have been compared with the electronically injected 8-valve engine and with the different values of the isopotential curves. One throttle valve per cylinder enables the adoption of particular timing conditions and substantially improves slow running on weaker mixtures, thereby greatly reducing the polluting properties of the exhaust gases. Suspensions. The innovations introduced to the 4-strut suspension system consist in the different direction of the upper links, which now face forwards rather than backwards. This has minimized noise in the passenger compartment, as all the struts are anchored to a particularly rigid area of the underbody. From a kinematic point of view, this new suspension does not differ greatly from the previous one, as the wheel's center pump positions describe almost the same path. In order to preserve the typical handling features with the higher amount of power available, the upper section of the front suspension has been changed through the insertion of a bearing between the shock absorber stem and the pad. Engine servicing. From the servicing point of view, the 16-valve Boxer engine does not differ substantially from the previous units. The procedure for throttle valve adjustment and camshaft timing is different. Removal and refitting the heads involve a certain extent of difficulty, as there's less space available. We've decided to illustrate these operations on film. Throttle valve adjustment. Any operating failures resulting in uneven fuel feeding may be determined by a number of causes. Here we're going to take a look at the checks and operations necessary to ensure that the throttle valves are working correctly. In general, however, we recommend checking that the crankcase air inlet and outlet pipes are well connected and sealed. Checking alignment. In the event of faulty operation at idle speed, a vacuum meter should be connected to the special vacuum sockets. If the difference in the pressure between the cylinders exceeds 25 millimeters of mercury, the bypass screw needs adjusting. On this engine, the bypass screw has a particularly large adjustment range. Therefore, realignment is easily done without cleaning the ducts. If, however, in extreme cases, it's not possible to reset the differential value to 25 millimeters of mercury, before changing the faulty barrel, the flow rate should be checked because the throttle valve might have been moved accidentally. This operation can be carried out directly on the car. Firstly, the duct and the throttle valve should be cleaned using a cloth soaked in methylated spirits or petrol. Then, two adjustments are necessary. Firstly, with the bypass completely closed, set the throttle screw to 120 on the Solex K scale. Secondly, turn the bypass screw until the reading on the Solex N scale is between 180 and 190. Checking the synchronism. If operation is faulty with the engine running at higher than idle speed and the accelerator slightly pressed, check that the two pairs of throttles are actuated simultaneously. In order to ensure that the two throttled barrels operate simultaneously, the idle lever's contrast screws need adjusting. These levers should not allow more than 1 millimeter clearance. Operating synchronism should also be checked using the vacuum meter. Adjusting the contrast screws, it's also possible to even out slacks on the kinematic drive chain, thus ensuring synchronized operation. Head removal. Before doing this, the components which prevent access to the engine and its connections should be removed, namely the cleaner, the flow meter, the intake manifold, the throttle control rod and cover, the radiator, and the belt. After removing the timing belt cover, before taking the actual belts off, the flywheel should be turned until the T marked on it coincides with the arrangement shown here of the reference marks on the pulleys. Loosen the belt tensioners and remove the right-hand belt and then the left-hand belt. The heads can now be removed. Fit the special backstop. Slacken the fixing nut and remove the pulleys and the rear section of the timing case. Slacken the cover bolts from above and below using the wrenches specified in the repair manual. Now the cover can be removed. Lastly, using the specially shaped wrench, loosen the bolts connecting the crankcase to the head and remove the head. To refit the head, simply reverse the operations described for the removal. When the belts are refitted, the camshafts need timing. So now, we're going to take a closer look at this operation. The flywheel position should coincide with the T mark. The arrangement of the reference marks on both pairs of pulleys must correspond to this position. At this point, piston number 1 will be at the top dead center in the bursting stroke. The belts are pre-tensioned by slackening the tensioner bolts. Then the system is locked. Now the flywheel should be turned to V. In this position, the V marks on the right-hand pulley coincide. In this condition, the tension of the right-hand valve springs does not bear on the right-hand camshaft. Final tensioning is achieved by slackening and relocking the belt tensioner. Turning the flywheel through a further 360 degrees, the V marks on the left-hand pulleys coincide. Now the tension of the valve springs does not bear on the left-hand camshaft. Here too, the tensioner should be slackened and relocked for final tensioning. We've already mentioned that the design of the Nuova 33 has been based on a number of technical developments. In this film, we've shown the solutions adopted for the 16-valve Boxer engine and the criterion with which the suspensions have been structured. In another series of films, we shall illustrate the new features which have been introduced to other components of the car.